Alright, so we're going to keep talking about similarity. So tonight we're going to talk about triangle similarity. The last lesson we were talking about polygons, which is anything, any closed, straight-sided figure, squares, rectangles, octagons, but today it's just going to be triangles only. And there's some really specific stuff about triangles that make similar triangles a lot easier. So I thought I'd try to think of a creative way to explain all this to you, but I couldn't, so I decided I'll just tell you quickly and we'll practice it in class tomorrow. So we're going to start out with a triangle. So here is my random triangle. Now if I duplicate this triangle and I make another one, I'm going to keep it on top of it, and I'm going to adjust it. Do you see how I'm shrinking it down? But hopefully you notice that that left angle, that bottom left angle down here, is staying the same. I'm not changing that angle. Okay, and that's going to be a factor in what we're doing here. So I'm going to take this triangle over here and I'm going to shrink it back down, so I'm not changing that angle. Like my favorite letters of all time, right? So triangle DEF. I'm going to set this so that it all moves together. When I move this over here, angle D and angle A are congruent, angle F and angle C are congruent, and angle B and angle E are congruent. What we're going to work with is something called the angle-angle similarity postulate. If we have two congruent angles in two triangles, then the triangles are similar. Okay, so we're going to write that down. We're going to write if two angles of one triangle are congruent to two angles of another triangle, then the triangles are, and this is where you have to be careful because a lot of people want to put the word congruent, but they're not congruent. You can see they're clearly not the same size, but they are similar. Okay, and this is called the angle-angle similarity postulate. Okay, this is one of your memorize things that you need to be working on. Okay, this needs to be memorized. If not by tomorrow, it definitely needs to be memorized by the end of the week, and very much so needs to be memorized by the test. So angle-angle similarity. If we have a triangle with two angles that are congruent, then the two triangles are similar. Alright, so we're going to do the next one now. There's two more. I'm going to make a copy of it. But I'm going to take and I'm going to shrink down. Let's see, that didn't go well. I'll shrink one of them down, but it seems to be moving it. So, alright, there we go. So I'm going to shrink this one down. So this one's clearly smaller, but you can see that the top right angle, top left angle, and the bottom angle are all still the same, so these are still similar triangles. So we're going to label triangle J, K, L, and triangle M, N, P. Right? And the way we're going to mark these triangles is with a side, side, side similarity postulate. Okay? So side, side, side similarity postulate. Now, when you look at these two triangles, it should be very clear to you that JK is not congruent to MN. Okay? They're not the same size. But when you saw me shrink them down. I shrunk it all at once, right? It's not like I shrunk it just this way, or I shrunk it just this way, right? I shrunk it everything at the same time. So what that tells me is that the side lengths are proportional to each other. I shrunk each one of them the same amount. If three sides of one triangle, so if three sides of one triangle are proportional to three corresponding sides of another triangle, then the triangles are what? Obviously they're not congruent, right? So they are similar, right? So that's side, 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 similarity postulate. I'm hoping that we're past the point of me having to continue to tell you this is a memorize. Okay? Not, I remember hearing Mr. Lewis say that 2 weeks ago, but memorized. All right, the last one is another one that SSS you've heard before. Maybe up here AA you never heard before, but SSS you have heard before. And this last one I'm going to do is also one that you've heard before. So start out with our triangle. Make it a little different, but not much. I'll duplicate it, and then I'm going to shrink it down, but still keep it all. That's not the one. Shrink it down and keep it all proportional still. All right, so all my angles are staying the same there when I do it that way. All right, everybody's happy. Angles are all the same. Angles are all the same. Got off a little bit, but for what we're doing, it's close enough. All right, that's not what I wanted to do. All right, so we're going to have, this will be triangle RST, and this will be triangle MNP. Sometimes we don't know that all three sides are similar, and sometimes we don't know that two angles are congruent. Sometimes the best we'll get is maybe this side is similar to this side, and then this side is similar to this side, and we don't know anything about this side. But the one extra thing that would help us is if we knew that this angle was congruent to this angle. That would mean that this side across here also had to be proportional. And what this gives us, hopefully you'll recognize, is a side angle side similarity postulate. Okay, and it's the trickiest one to write down, but it's still pretty basic. It says, if two sides of one triangle are proportional to two sides of another triangle, and their included angles. Okay, so that is the included angle. That's an important one. We didn't do great on the last test with this SAS. Remember, the angle has to be between the two sides. So their included angles are congruent, then the triangles are similar. That's a lot of writing. It's a lot easier just to memorize two sides of an included angle and then remember SAS. So everybody likes proofs, right? So I'm going to draw a picture here. All right, and for the sake of argument, in this picture I drew, we're going to say that this side is parallel to this side. So this will be A, B, C, D, and E. So AB is parallel to DE. We're going to make a fancy little 2-column proof, like you love to do. So our first statement number 1, the reason is given. So I have that this line is parallel to this line. Well, right away, I'm thinking here, I want to prove these are similar. So I want to go for one of these, SAS, SSS, or AA. So I'm going to go down and look here, and right away I see that this angle is congruent to this angle. Okay, so I know that's true, so I'm going to write it down. Angle ACB is congruent to angle ECD. Well, why do I know that? That's the vertical angles theorem, right? We could have put a line in here that said angle ACB and angle ECD are vertical angles, and then that would be the definition of vertical angles. But this is good enough for what we're doing. All right, so now I have an angle that's congruent to another angle. If I could get another set of angles, like if I could say this angle is congruent to this angle, I'd be done because I'd have my AA. But is there a way I can say that those two angles are congruent? Well, remember these lines, these segments here, even though they stop, they're really part of these lines that extend on forever, right? So these are parallel lines. And then this is a transversal that goes through them, right? So I have these two parallel lines. They're cut by this transversal. So they're alternate interior angles have to be congruent. So I can say angle B is congruent to angle D, and my reason is alternate interior angles theorem. And then my last line will say that triangle ABC is similar to triangle EDC, and the reason is I have an AA that's congruent to an AA in this triangle. So my reason here, I have this angle, so AA is my reason, and I'm done with the proof. So think about that. Think about any questions you have, write them down, and we'll talk about it tomorrow.